from BlueBolt. Jason is the Chief Solutions Officer at BlueBolt, and he's going to talk to us about machine learning, like Terminator kind of thing.
That's exactly it.
Thank you, George.
So when I saw the schedule and I saw that I was following Joey, I got a little nervous because I was at the disruption event, and he was a pretty good speaker, so I pulled him aside and asked him to suck a little bit.
Thank you. I did well, thank you.
I don't think he listened to me at all. So I think great lead in here. So he brought us through an actual exercise to show how something real can be done, not theoretical. We're going to start out today talking about machine learning, and that maybe seems a little sci-fi, futuristic, but I'm going to show you how it is actually a part of your lives already. We'll talk about how you can potentially make it part of your association's life, and then we'll at the end talk a little bit about a proof of concept that we actually went through with the association that we work with. A little bit about me. I am a founder at BlueBolt. We are a technology enablement company that manifests through helping organizations with CMS implementation. We have a site search solution. Basically, we're trying to connect technology to organizational goals. Enough said there. I think I already hit the agenda, so let's just kind of get into it here a little bit. So, is Wild? My notes aren't showing up. It would be helpful, but if it's, I can maybe wing it if not.
No.
Okay, all right, then we're going to wing it. All right, so what is machine learning? Let's see, now this is really where I test my memory. So essentially, it boils down to, machine learning is a subset of artificial intelligence, and it's the part that's concerned with throwing machines at large data sets in order to detect patterns. As the name implies, it's the idea that machines are going to iterate themselves through an algorithm and sort of produce some sort of intelligence from that. This pattern detection leads to a couple different things. One, if you establish a pattern and understand what that looks like, then you can start to recognize anomalies. Second, you can start to investigate something that I call the reducing the friction of choice. And we'll talk more about that as we go. The name itself, we emphasize the machine part, but let's take a look at the last word, the learning. Well, if we're learning, who's doing the teaching? Well, that's us. And so there is a very human element to machine learning. Any type of machine learning algorithm does start with a human being sitting down and taking the first crack at what the algorithm will be, as we illustrate here. So coffee is generally part of the process. And after that algorithm is established, there's an amount of ongoing training that takes place where human beings are literally explaining to the machine how, whether they did something right or wrong, and it's then up to the machine to figure out, well, why they got it wrong or why it was right. And after a certain amount of time, it starts to figure out the pattern based upon the data that it's looking at. Yeah. Thank you so much. All right, very good. Just to make sure you don't destroy your laptop here. So let's look at some real world examples. Because every day, you guys use machine learning to get here today, perhaps. And thank you, we got the notes, Lyle, appreciate it. So let's talk through some examples. So one easy to recognize example is Facebook. They're probably using ML in many places, and you're going to hear me shorten it to ML, so machine learning. When Facebook gives you recommendations regarding your photos, your friends in your photos to say, is this Bob, is this Susie? That's machine learning in action. It's an algorithm that has learned basically the look of your friends' faces and is making preemptive suggestions to you. Another common use of ML is fraud detection. So every credit card you own and your bank statements, they're constantly reviewing your data. They've established your trends. They know where you live and where you travel. They know the places you shop at, and then they're looking for anomalies that say, well, maybe that isn't Jason. Maybe we should give him a call and find out if this is a real charge. That's machine learning in action in your life. Ride sharing, so Uber. I used to think that Uber's goal was to get to the point where they were giving you those surge pricing, but they're actually trying to reduce that because they want it to be a more reliable expected cost. And so the way that they're working on reducing that is using ML to recognize patterns and usage, and then identifying where they need to deploy drivers. So saying, well, in the loop at 4:30, we need to get so many drivers there, which seems pretty straightforward, but they're getting the numbers down specifically even by street, with the goal of making their service more reliable. Email sorting, another good example. I use Outlook, and I think most of the other, like if you use Gmail and so on, they've got their own ways of doing it. But for Outlook, they're not only taking the junk and just moving that aside, and that's partly done through ML as well, but then they're trying to say, well, these are the really important messages, and these are the less important messages. So using ML and recognizing your patterns to say, well, if you get an email from your mom, you always open those, and you open it right away, so we're going to put that in the important. You get an email from your old buddy Bob from high school, you tend to ignore those, so that's going to go into the less important folder. And then last sort of real world example is in medical diagnosis. And hopefully this isn't something we all have every day, but that is very much an aspect of pattern recognition as well. So, and it falls into the image analysis. When you're looking at a sample of blood or some other tissue, human beings get very good at detecting cancer and other sorts of ailments there. So we can teach the computer to actually do the same sorts of analysis and do it more cost effectively and faster. So hopefully saving lives there. So these are real good examples of how machine learning is already in use in the world and affecting our daily lives. All right, so what does that mean for associations? Really, the people in this room are going to help decide that, right? But I have a couple of ideas that I'd like to just throw out there. So, detecting trends in member activities. First of all, in the aggregate. And so what are the events and content that is popular, trending more popular, or trending more unpopular? That will help you understand what, maybe you've got to do some more marketing for your events, or that you maybe should be producing more particular kind of content in order to get the results that you're wanting. Or maybe you should kill off certain programs because it was popular last year, but it's just not trending well this year. You can also then detect trends at the more individual level, and I think this is where it gets really interesting. So perhaps you've identified key engaged members, people that are serving in different committees or on different boards, who you've relied on for 5, 10 years, et cetera. Wouldn't it be nice to know if Susan suddenly is dropped off the face of the map? She usually shows up at certain meetings, she usually attends certain webinars, and is reliable in terms of filling out forms, and there's been a noticeable lack in terms of her engagement recently. These are the types of things, anomaly detection, that machine learning algorithms really do very well at. And so you can get notified of that and then perhaps take action to bring Susan back into the fold. In a related note, perhaps you can detect customer service issues. So if we've got a pattern of a user sort of bouncing around certain systems, they were in your community site asking certain kinds of questions, then move to your AMS, then we're on your website. Perhaps there's a user that's got some sort of customer service issue that they're trying to resolve, and you can proactively reach out and help that person. Transactional notifications. So this is, I think, where we're getting even further sort of into the machine. So if you have identified that a certain individual is as a lock-in to sort of show up at a certain event, and you're based upon their past behavior and sort of their pattern recognition, and you've noticed that they haven't showed up, or they're not yet signed up for this event that they're probably interested in, maybe we can take the step of actually sending them a text message or something a little more highly interruptive than we normally wouldn't want to do. But if the machine knows that I'm pretty solid for this event and would want to go, and knows that I'm kind of probably running late as I do on most of the things in my life, I would appreciate a text message. And so detecting those patterns in terms of usage, detecting patterns in terms of wants and needs, that's where these machines are going to start to influence what we can do with our members. All right, and in the last sort of section of potential that I see is curating and delivering relevant content. And this is where I get to, I call this reducing the friction of choice. So what do I mean by that? So let's think about Netflix. I know when I go to use Netflix to watch a movie in particular, I might spend a good half an hour trying to figure out what movie I want to watch. And part of the input into which movie I'm going to decide to watch was I don't want anything longer than 2 hours or something like that. So I've already wasted a half an hour of that, right? So ideally, I would just turn on my TV and it would start playing something, right? It would know that it's dinner time, I like to watch the news at dinner time. It's Friday night and I want to watch sports, and it's Saturday night, so it's rom-com night or something like that. And it would pick out the perfect piece of entertainment for me at that time. Well, that's what we need to start doing for our members, and that's where machine learning can help as well. So detecting the patterns regarding what a particular member is interested in, and keeping track of that, keeping track of what content seems to be trending generally, and then sort of cross-referencing those to say, well, this is the hot piece of content for this piece, this particular segment of information, so let's make sure that gets sent to the member. And so then what's the delivery mechanism? So detecting what the user's preferred delivery method would be. So it could be that, well, we'll just wait till they show up to the website and then make sure that that's splashed on the homepage for them. Or, no, they like email. And we've noticed because they always open their email and they never flag us as spam or anything like that. Or maybe this is something that's, again, so important that the user would actually probably appreciate a text message on this. You want to get that right, obviously, but that's where these kind of algorithms can help you figure that out. Okay, so this is, as I said, it's happening today. We've got evidence in that in our real lives with big companies that we interact with every day. We are, at BlueBolt, attempting to push these ideas into the clients that we're working with. And so we did entertain a proof of concept recently. We've done a similar proof of concept with a couple of organizations, and I'm going to talk through a path we went down with the American Epilepsy Society. Is there anybody here from AES? I didn't think so. Okay. All right, they have their annual meeting coming up. So our goal here was to combine content from 2 different content sources, from their website and from their journal, and see if we could classify that content against a common taxonomy. Now, know up front that they don't have an organizational taxonomy at this point in time. And like many organizations, they would like to get there, but one of the barriers to getting that is the idea that, well, it's great. We take a lot of time to develop that taxonomy, and then there's the impossible task of actually assigning those tags to all of our content, because we've got tens of thousands of pieces of content. So what we're hoping with this exercise of auto-classification is if we can train the computer on how to recognize the classification of content, then maybe we can simplify that process, speed it up, and actually make the taxonomy more valuable. Here we go. All right, so the path we went down was first we had to collect the content. So we built some web crawlers, scrapers, if you will, and we scraped all the content from the website. We scraped all the content from their journal website. And in both cases, we limit ourselves just to the HTML content. So there's no technical reason why we couldn't have dived into the PDFs, but we just kept it simple, got the HTML. And as far as the journal, we just stuck with the abstracts just to try and limit the scope. So we collected the content. Then we went down the path of training the machine learning system that we were working with. And actually I skipped step 2. We had to actually create a taxonomy. So as I mentioned, they didn't have an organizational taxonomy in place. So we didn't have the SMEs really available to us. So we took our best stab at it. Easy one was to say they work with a lot of different medications. So we were able to get a list of medications that apply to epilepsy and put that as part of a node in the taxonomy. So we ended up with, I think, 15 to 20 taxonomy nodes, just a subset of really what it would require to really classify all the content, but good enough for a test. So we then trained the system to recognize applicable classification. So what that means is for every node, we took a sample piece of content and said, all right, for a particular drug, this is content that's about that drug. Now, one highly suggestive Part of that would be, well, the drug's name is in the content. So if it's, I can't remember any drug names off the top of my head. If it's Bayer aspirin is in there, then it's very likely that this can be classified as Bayer aspirin. A little more floopy is patient resources, which isn't just one set of words. So we took a certain set of content, about 20 pieces per node, and said, this is an example of patient resources. This is an example of content about the medication. This is an example about professional continuing education. When the system was trained then, got about 20 sample pieces of content per tag, we then basically said, now go classify the rest of it on your own. And I think we had 1,600 pieces, 1,400 pieces of content altogether. And it was able to classify about 25% of it with the tags that we gave it. And then the next step is to sort of, well, let's look through it and make some judgment about the results. So this is the report that we generated off of it. I'm not able to show you a live copy, but that's okay. We can get through it here. So altogether, we had 1,400 pages of potential content to classify. We were able to classify 25%, which is reasonable given that we only had a small taxonomy list. And from there, you can see the breakdown on the left of the different taxonomy terms. We had a two-tiered taxonomy. And so what you'll see here is medication, levetiracetam, and we had 19 pieces of content that were classified according to that tag. I can click on any one of those, and then on the right-hand side, I get a list of all the content. The very leftmost column on this right side is the accuracy. That's a part of the machine learning. It assigns essentially a score to itself. 100% would be perfect. Upper 80s is where we ended up for most of it. Well, actually maybe mid 80s, I think is where the average was. And that's pretty darn good, actually, for the first pass. We can get this even better as we keep going. And then it's built into our report. Into the report, we're actually able to click the link and make our own judgment. So the idea is, we saw in the second one here that it was classified as this particular medication. We can open it up and confirm that, yeah, it did a decent job. In many cases, it'll be classified as under multiple tags, and we can check that out as well. If we notice any issues, then we can obviously go back into certain tags and say, well, we need some more training here, or perhaps we need to modify the algorithm slightly. But we got a number of different reports basically to say, well, here's where the tags were the strongest, here's where the weakest. But the end result was, it was judged a mild success. But we're going to kind of continue to keep going to see what we can do further. So I told you that we had the 1,400, we were classified 25%. Yeah, somewhere in the 80s is where our average accuracy was. And the proof of concept demonstrates the possibility of actually establishing a common taxonomy across multiple content sources and getting that content, that taxonomy assigned, classified in an automated fashion. We think that with more time and with use from a true subject matter expert, we could actually get this to be extremely accurate, possibly into the 90s, and then set it loose. So potential applications of this is, well, you've got all your content classified. You can perhaps have a more interactive search interface to be able to filter your results by different facets and so on. Potentially do some of that content curating that I was mentioning earlier, saying, well, once we know that the users are interested in X kind of content, we've identified that content and can get that delivered to them more efficiently. Next steps include more data sources in the process, include the actual subject matter experts, and then improve that training exercise. So I think that's about it. In summary, okay. Machine learning is here today. You're already using it. It's going to make its way into your world, I mean, whether you like it or not. It's going to start to be added to the products that you use. And so I think it's time to start thinking proactively about how you can actually leverage it in the kinds of places that could help you and your organization. And let us know if we could potentially help you on that. Thank you very much.